Welcome to another simple engineering instructional snippet. In this instructional video, we will calculate the volumetric flow using the pressure change across a pipe contraction. We have a sharp contraction as shown. We will be using the pressure difference between the large diameter section and the small diameter section to determine the flow. Pressure indication is available for points 1 and 2 as indicated. The difference in pressure between point 1 and 2 is 3.4 kilopascals. The minor loss coefficient for the contraction is 0.4. If this were not provided, we would look this up based on the ratio of the two diameters. The flow is also incompressible. We will assume that the length between points 1 and 2 is small, so the frictional effects between the fluid and the pipe wall is negligible. The difference in pressure between points 1 and 2 is solely due to the contraction. Before we move on, let's review that the minor loss coefficient for the pipe contraction is based on the velocity in the smaller pipe, in this case, section 2. To solve this problem, we will be using conservation of energy, head loss due to a minor loss, and the continuity equation. These are provided here. Let's start with the continuity equation. If we know the velocity at either point 1 or point 2, then we can calculate the volumetric flow rate. We'll solve for the square of the velocity at point 1 in terms of the square of the velocity at point 2 and the ratio of the diameters. Let's start to simplify. First, it is clear that the elevations at point 1 and point 2 cancel. Now we substitute the expression for velocity 1 squared and solve for velocity 2. Now let's plug in the numbers. But before we go further, let's check our units. Units are good. Solving for the velocity of 2, it is 2.43 meters per second. Multiplying it by the area at 2, we get that the volumetric flow is equal to 1.19 times 10 to the minus 3 cubic meters per second. We have solved the problem, but what would the results be if we ignored all losses and used Bernoulli's equation? Doing this, we see that the calculated flow would be 24% higher than the flow calculated accounting for the minor loss. I hope you found this instructional snippet useful. If so, then please like and subscribe. Thanks and have a great day.